Jesus Gonzalez, and this is our car toy project.
Hi, my name is Diego Soto, and this is our car, the Corvette. So first off, we're gonna start off with our first surface, concrete, and let's give it a spin.
As you can see, it got to 62 inches.
Yeah.
Alright guys, this is our second surface, which is ceramic tile, and here we go.
Damn, it feels buzzed. Alright, so as you could see, it's 65 inches, I think. Nah, hold up. 60. I'm gonna say like 63. Yeah, 63. Alright guys, now we're going to our third surface, into gravel. We're out here in the middle of the street. So let's get this thing rolling.
As you can see, it was about 34 inches.
1 day later.
Alright, to start off, we have a precision time graph for all three of our surfaces. To start off, we have a cement one. We have the position in meters and the time in seconds. So for cement, it stopped at approximately 3 seconds. As all surfaces, since it was in ramp, obviously the car had the most speed in the beginning, from 0 to 0.5 seconds in mostly all of them. And well, for cement, you could see here that it had it increasing position in meters as it went along, obviously, until 3 seconds, where it stopped at its stopping point, and it was just consistent at 1.58 meters. Going down to ceramic tile, pretty much the same thing. It was kind of the same for this one. This one also ended at around 3 seconds. However, this one went a little bit further and went to 1.6 meters exactly. And this one, kind of the same arc, but probably the tile, the little cracks, is what made it stop in such a weird way like this. And then going down to the gravel, obviously that one has a lot more friction in it. And well, as you can see in this graph, it stopped at 2 seconds. So at 2 seconds, it was already stopped at 0.8 meters. And well, yeah, this is a lot shorter arc. Alright, moving on, we have a velocity time graph. We have a velocity meters over seconds, and our time in seconds, obviously. So going into cement, this was the only one that was kind of weird, where it, in the time 0.0 to 0.5 second, the interval, the velocity was slower than it was from 0.5 to 1 second. Maybe it was because of the ramp as it hit impact, but that one, this was the only one that was like that. But yeah, obviously, as the friction stops the car, the velocity is decreasing over time. And finally, at 3 seconds, it was already at 0 velocity meters per second. Yeah. Moving on to the ceramic tile. This one was just pretty straightforward, consistent. Started at 1.4 meters per second from the interval 0 seconds to 0.5, and just slowly went down, stopping at 3 seconds as well. And then to gravel, this one was the one that you could obviously tell had a huge gap of where it stopped. So it started at 0.8 meters per second from interval 0 to 0.5, and it shot down from 1 second to 1.5 seconds, straight down to 0.2 meters per second, and from there just straight up stopped at 2 seconds. And so yeah, that's the time graphs.
Okay, for the first one, the first example, which was the concrete in the backyard, what we used to find, or what I used to find acceleration, which we used this formula, which was final velocity minus initial velocity divided by time, which in total for the first one, they traveled a total of 1.58 meters, and minus 0, since that, and divided by 3 seconds, which in total gives us 0.53 meters per second. And since now we have the acceleration, we can now use this formula to find the coefficient kinetic friction, which was F applied minus mk times mg equals mass times acceleration. We added it on both sides to get rid of it on this side, and then we subtracted mass and acceleration on this side to get on this side, and then we divided it by mass times gravity to get the mk alone. And then we plugged in each one, which gives us this. And then we plugged it into the calculator, which it gives us this answer, which was 0.055 newtons. So now that we have the coefficient of kinetic friction, we can now find the force of friction. And we use this formula, which was mk times mass and gravity. And we plugged it in, these numbers in the calculator, and it gives us the answer of 0.03 newtons for friction. And that was for the first surface type, which was the concrete in the backyard. Moving on to the next one, which was the ceramic tile, which was inside. Same formula, same everything, just that this time it traveled a total of 1.6 meters in 3 seconds. And it gave us an acceleration of, well, basically the same, just 0.53 meters per second squared. And then now the acceleration, we used the same formula to find mk. Plugged in all the values and in the calculator, which gave us the same answer as the first one, which was 0.055 newtons. Now that we have the coefficient of friction, now we can find the force of friction. And we plugged in these values, which is this one, and it gives a total of 0.3 newtons, same as the first one. And that was for the second surface type, which was ceramic tile, which was inside. And moving on to the third one, which was the gravel on the road. This time to find acceleration, the same thing, just that it traveled a total of 0.86 meters in a total of 2 seconds, and we divided it, and it gives us 0.42 meters per second. And now we plugged it into this formula where we can find the first the coefficient of kinetic friction, and plugged it into the calculator, these numbers, and ended up giving us 0.043 newtons. Now that we have that, we can now find the force of friction, and now we plug in each value, and it ended up giving us a total of 0.23 newtons of force of friction for the third one, which was the gravel and the road. And that was it.
In conclusion, the surface of ceramic tile allowed for the greatest distance. This was because it had the lowest coefficient of friction, resulting in the least amount of force opposing the car's motion.
Who's on call with us right now?
Yeah.
Look who's on
He
call with us
randomly
right
called me. He randomly hit me up.
Ronaldo is
now.
crazy.
Ronaldo, he just winked at you. Why did
He winked at
Ronaldo
you.
wink at you? Why did Ronaldo wink at you?